Okay, guys. Today is kind of a supplemental video. I hope you guys watch it because it kind of will. It's better to understand these things and than it is to just memorize them. Memorization is a pretty basic skill that most people can do. But we always talk about in education. You want to know, you want to understand, then you want to be able to apply those things. So it's kind of a hierarchy of learning. So if you know it, that's great. But if you know it, you should be working on understanding and applying it. So let's talk about why this works. So in a trapezoid, we went ahead and we said there was a couple things. So for just any basic trapezoid, we said that it has two parallel bases, right? And we said that if we took on the same side of a trapezoid, if we took the two consecutive angles, that they were supplementary. Okay, that this angle plus this angle would equal 180 degrees. So let's talk about why. I'm going to kind of, let's see if I can extend this a little bit. I'm going to draw this line kind of out this way, and I'm going to kind of superimpose a set of transversals over it. And this would be the same for both sides. I'm only going to do it for one. But all of a sudden now we have parallel lines cut by a transversal, right? So if we think about these sides not as being the individual parts of a trapezoid, but as parts of parallel lines cut by a transversal, well, you guys know that these angles are all congruent, right? These are vertical angles and they were corresponding angles, right? But we also know that all these guys right here, these were all congruent, right? And that if I took any two of these in a row, they would be equal to 180 degrees. So if we kind of take all that away and just look real quick, we see I've got a red angle here, and I've got a blue angle here. So any red and blue angle together have to equal 180 degrees. So whenever we hear the words parallel, immediately these are things we should be thinking. And it's the same thing over here, right? I'll draw another such so you guys can see. Again, if I just kind of extend these through, I'm just going to move this. No, not that one. If I just kind of move these over, it'll be the same rule over here, right? Just it'll be a different transversal. So again, what we said about one side is individualized in the other side, but it's the same rule, right? That we would have parallel lines cut by a transversal over here and transversal over here, okay? With an isosceles trapezoid, that is still true. We just get this added bonus of things, and that comes from your base angles being congruent. So first of all, how do we know the base angle is congruent? So by definition, all they tell you about an isosceles triangle is that these are parallel, and of course it writes like a crayon, and that these are congruent. Like that's what they told you, right? So let's talk about, first of all, one of the things we should be able to know is that your base angles are the same, and how we do that is pretty straightforward. There's a few different ways. I'll pick the most direct one. I'm going to drop a vertical line there and a vertical line there. We would call those the height where I come from, okay? So now, this is a right angle here, right, because they are parallel. So essentially I created a rectangle in the middle, which means that these two sides are congruent as well, right? But it also means that I made two right triangles here, so via the hypotenuse leg theorem here and via the hypotenuse leg theorem here, right? Like I have a right triangle and I have the hypotenuse and the leg. Therefore, we know that those two triangles are the same. Therefore, I know that my two base angles are the same, okay? So again, not something they directly tell you in the definition, but something we can definitely infer, and we could just kind of remember that as a fact. Like I said, a lot of these things, they're just, for you to know. So that is super important, right? But again, now what we do know is that we can mix and match, because those things we said before with transversals, right? These are kind of two of the same thing facing in opposite directions, right? Again, if I'm going to think about what we were calling our red angles and our blue angles before, okay? So again, all my red angles are going to be here, right? Corresponding up here, right? They're just kind of facing in different directions. But if you notice, both of the bottom angles are red angles, and both of your top angles, they're going to be kind of our blue angles. So what it tells us in turn is not just are the base angles the same, but that if I mix and match any top and bottom one, that they will be equal to 180 degrees. Okay. So again, extra little nugget of information. The last piece of information they told you, get rid of all this stuff, click, 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 click. Excuse me, was that if you, I'm sorry, let me add that extra piece of information, let me know. Okay, so again, these are, I'll put a different symbol there just so you guys see. The other things they told you was that your diagonals were also congruent too, so let's talk about why that's true. One second. Okay, I just want to pick the most direct way to do this. So I would reckon the most direct way to do this is we're going to do a little proofs about two triangles inside here. So we do know this, right? We actually don't have to know the other rule, which is even better. If we said these two lines are parallel, right? Well, therefore, again, if I see alternate interior angles here, so here's a parallel line, here's a parallel line, here's a transversal that comes between them, so I know that these are the same, right? But in fact, since I also knew this, I also know that these would be the same as well, right? Okay, which tells us that those are isosceles triangles, right? And in fact, if we want to take it a third step, we can actually say that, I'll put a different symbol here. These two triangles, the two that are kind of making this hourglass shape, they are similar, right? They have angle, angle, angle similarity. But also more importantly for us, because they were coming off of congruent angles up here and congruent angles down here, these are also going to be isosceles triangles, which means that if they have two common base angles, the sides across them have to be congruent, right? And again, if I take it up here, same thing. These have to be the same length. So again, if I start adding those two things together, these two same lengths with these two same lengths, I will find out that these whole parts are congruent. There's other ways to prove it as well. I just thought that was kind of the most direct one. And the last thing I want to go over is why that last rule, that this was the average of these two. The first thing you're going to have to kind of remember is what we call the size splitter theorem. I might add this as a review topic some point this week, because we did it, I don't know, in like September. Okay, and that was essentially this. If these were the same length, right, and these were the same length, in other words, these were cut in half, that this was one half of this, and this was a 2-to-1 ratio, okay, that this was half of this, okay? So if you know that, then we can kind of go a little bit further with this, okay? Now, the first thing you see is that there are no triangles here, right? The first thing you want to do is we're going to go ahead and we're going to make a big triangle there. I'm going to try to anyway. Okay. Okay, so first of all, do we see this big triangle? Now, in your theorem, it went ahead and it told us the same thing. So it said that this right here was the same length as here, and this right here was the same length as here. And they told you that essentially if I averaged the top and the bottom, if I added the top and the bottom together and divided by 2, I would get this part right here. Okay? So the first thing we want to notice is that, oops, oh, I give it a headache. Is that triangle that we drew here. So here's our triangle, right? Yes? Okay, so by definition, let's talk about some things we know. By definition, we know that this line, and this line are all parallel. So first of all, let's go ahead and start and let's say that this angle is the same as this angle, which probably isn't all that important to us, which is the same as this angle way down here, right? You guys see the transversal, kind of that Z. Okay. The next piece of information, I do it in a different color, is that this one right here is a vertical angle with this one right here. And if you notice, we'll say this is, I don't want to go crazy with labeling them, but if you see between this triangle up here and this triangle down here, we have something. We have angle, angle, side, angle, angle, side, right? Red angle, blue angle, 1 dash, red angle, blue angle, 1 dash. So we actually know by the angle, angle, side theorem that these two triangles are the same. So what we can do now is we can go ahead and we can label up some of the things that we know. So we know that this side right here, so this top length right here is the same as this bottom length right here, correct? So what do we know? We know now that extra piece of information that we needed, okay? So what if I, for a second, just kind of highlighted this one triangle? Do it in a different color. Well, again, this triangle is true, right? That this middle side, right, by our side splitter theorem, this middle side should be 1/2 of this whole thing. Well, and again, this whole thing is the top and the bottom, okay? Right, so it's the same length as this. So I got my top and my bottom, so what does that tell me? That tells me that these two parts, right, added up, then divided by 2, make this one. So let's go ahead now. Again, I don't want to clog it up with letters before, and I'll go ahead and I'll do that now. If I call this A, B, C, D, E, F, G. What do we know? AB is congruent to FG, right? We proved that, right? So this and this are the same length, right? And what are we going to go ahead and say? That CD by the side splitter theorem is equal to 1/2 EF plus FG, right? But since we know that AB and FG are the same, we can also say that CD is equal to 1/2 of EF plus AB. So again, just a useful thing to know. Again, is it the end of the world? No, you could just memorize the rule. But again, if we understand these things, then we should be able to take this to the next step. So anyway, I hope that helped. I hope it didn't confuse you guys too much, and I will talk to you tomorrow.